Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to this demonstration in which we are going to discuss two main things, how to generate a tin, and we will also discuss the boundary issue and other things. And I can show you on two different softwares, but the results are going to be the same. So we will be having this demonstration on ArcGIS. You can try on like QGIS or other softwares, and I am sure that it will generate the same results. And second thing which we will be discussing about DEM resolution. So I would be showing different digital elevation models, and we will see that how these resolutions will affect the representation of terrain in our real GIS operations. So let us start a demonstration on this. Here I am having points which earlier also we have been taking these points. So first we will go through the attribute file, or this what are the non-spatial data associated with these points. And what we are going to do, we will use this Z value associated with each points in our database, and then we will use this one to create a tin here. And there are two extensions within this software which will allow to create tin. And the best thing which I find is that this is the best way, rather than searching your tool. You can do this directly here in the search, that create, for example, you type here create tin, and once I go for search, I should get that which are the tools which are available here and there in my toolbox to create tin. For example, there is a create tin in 3D analyst also, and elsewhere also. So I don't bother about that. I would go only the best option generally is the first one. So let's go, because this is tin to raster, tin to edge. I am looking how to create tin using the given points, and points are already being displayed here. And once that option comes, we will provide some information to that one, and then can do that kind of operation. Sometimes the software is very huge, so it may take some time here. Okay, so now options are available to us, and this is where it will keep the output. So I am choosing wherever let it keep, and I can also choose the coordinate system or other things, and though currently it is optional, so I am just leaving it. Now input feature class that I want. So of course here I am having this input feature class, and there this one and the field is more important here, which we have to provide the height field. Height field information, as discussed, the Z value we will keep here. That is very important to provide here. Otherwise there might be because it does not know where to do or not, or where to search the Z value. If it is in very first field, by default it will search. In our case it is in the last field, so it will not be able to search automatically. So you must provide the field or column where the Z values have been kept. I am not going to change any other options or going for optional. So, let us first create with whatever the default things are there, except providing the height field or the field which is having this my elevations. And then once you have provided, you can create these things very easily. Now see, it has created a tin model for given points which we have given. As I was mentioning, that in the tin, the only problem which you are having about the border areas where you are having, or at the boundary, because the unit here has to be triangle, and therefore here like here did not have any other observations. So, let me change the color of this point. Instead of this color, if I choose red, then hopefully it would be more clearly. So, here I am having 3 points, a triangle has been formed, I do not have any other point. So, that my area of interest, what I mean here is that my area of interest may be a rectangular one, but tin will not be created for rectangular area. However, a digital elevation model can definitely be created for that area. So, this is the one limitations which you are having with the tin here. Now, I can also demonstrate to you some other things here, like for example, which we have been discussing in our this theory classes, that if I would like to go for this random selection or random creation, then I can do it. For example, I am adding a digital elevation model here, and this is the issue which I was mentioning. Here what I have done, in the background I have added a digital elevation model which was created earlier using the same these points, input points, and the same field, that is height field and Z value. And when you create, you can give you can instruct the software to for the extent of your digital elevation model. I mean here is that whether you want a within your data file or input data extent, or you want some extrapolation also. So, I could have generated the same points with a DM covering a large area, but if I would have created, then that means I have created extrapolated surface, not interpolated surface. But if I am keeping my digital elevation model within my extent, then it is in really under control, and not much extrapolation has been done here. Now, when we compare with this surface, see the tin and your interpolated surface, though the source of both of these models or surfaces are points which we have taken, and the same field and everything same, but the products are or outputs are completely different. So, tin which you are seeing top of this do not have coverage beyond these points, input points, whereas your digital elevation model, because it can be is a two-dimensional matrix, and therefore it can be either stored in a rectangular form or in a square shape. Here in this particular example, it is in rectangular form. So, that brings that thing of very clarity here. Further, the boundary issues which are related with this are always there with the tin, which are not a big problem in your simple raster or a digital elevation model. Now, what we can do, we can generate some random points, and then try to do how we can create such things. So random points can be generated. If you are having some extent, details about the extent, you can ask the system to generate random points within that extent, or maybe collect some points also. So, for example, if I say create random points, create random. Now, create a random raster or create random points. So, I would go for this one, and then we can say that which are the things which we have to follow. So, let it store in the default place. This field says what is the basically the output point feature class. So, this we have to the name of the random points featured classes to be created. So, we just give in here name is random 1, or maybe when if I am creating say 100 points, I would say random 100, and then whether I would go for some constraining these features. So, for time being, let us keep it simple, and I am not going for constraining my features. Or what we can do, we can provide the extent that create a random within that extent also. So, inside that area only the random points will be created or will be generated. And then what we can control here is the number of points. So, number of points that is the how many points. So, in default it is giving 100, let us keep 100, no issue is there. And then the units which we have to be providing here, what are the units. So, I can say in meters or whatever, so let us keep in meters here, units are in meters, and minimum allowed distance or value I am saying whatever the default, that is 0, and I can also have this option, that multi-point option, that so if I check that output will be geometrically type multi-points, all points are a single feature. So, I want that one, and the maximum number of points per multiple option, and let us do that without this check, and go for most simplest generation of these points. Let us see what happens. And they are being generated random points, and they have been now, see these points have been now added here, and these points unfortunately they are at the same locations they have been generated, and in fact these should have been generated at different location. Probably we constrained because we kept this. So, let me remove this one, also remove this one, and I will sometimes these things keep happening. So, what I will do, I will go again. And this time I am not basically going to take anyone. Let's keep things very simple. Here no, except here I can say meters, and let's go it. See, when I gave little freedom to the software, it has now selected or generated 100 random points within that constraint which I have, or within that extent which I have provided, which was already there because of the display of those DM and other data sets. So, why I wanted to show this, that you can select randomly 10 points or some random points. You can play with that. You can create random points, you can select random points, and you can use these random points to assess the quality of a digital elevation model, or even in that case a tin. So, in that way you can assess that how good it is on the border areas or margins there, but generally you would find that in tin the margin issue might be there. And of course, the resolution of a digital elevation model, which you can always control. I am not just will go up to the options interpolation, but will not do it because it takes a lot of time. So, you try by yourself. So, if I go for this interpolation, then we will see the which interpolation. So, I go for the a simple interpolation, maybe a moving window kriging. Here you have to provide the points whichever the available, the source and input data set, output, location, and other constraints are there, and that will allow. Or other way is the another way of reaching to menus. If you can remember the where those are in the toolbox, then you can again employ in that way also. I am more interested to show you about this interpolation options through this IDW or SP line method. So, just waiting. Yeah. So, here when I go for this spatial analyst, here I get options, and there I go for the surface and interpolation, sorry. And now I am having options IDW, kriging, natural neighbors, spline and others. So, if I go for IDW, this is what it will do. The input feature points. So, I say random points. Z value we have to provide, whether Z value is there. In this case there is not yet we have collected Z values, but if it would have been, then you can use those Z values, and then where it will be stored. And here this is the point which I wanted to discuss about the resolution. When we ourselves are creating a surface, we are having full control over the resolution. But that does not mean that I am having just few points and I am creating a digital elevation model at 1 meter resolution. It will not be a very good result. So, if I want a very high spatial resolution digital elevation model and the resolution I can control through software, I need high density of my observation points. If that is not there, then there is no use of increasing spatial resolution here. So, this one has to be very careful. Generally, the default values which will come based on already displayed themes or data sets, and because it is assuming that you are going to use these data sets along with a newly created digital elevation model. So, it assumes and it brings an already filled value, but definitely you can change that value. Also, you are having options of power and other things, how you want to constrain, and how tight you want and how loose you want interpolation against the input points, that you can also decide, and there are some other options are also available. So, by which if you choose, now here at this stage, before this stage, you can have 90% points, generate digital elevation models using different options of different interpolation techniques, and at the end you may have 10-12 surfaces. Now, using those 10% points, you can check how close a particular digital elevation model among whatever you have generated. So, whichever one it is close to you, you can definitely do that one. And you can, once you have decided or once you have found that this is the digital elevation model which is most suitable for that particular data set, then you can employ all 100% points and generate. Now, here I would like to mention, after all, whatever you are going to do is interpolation, and only it is telling that among the surfaces which you have generated, this is the best, but again that may not be the best. So, it is impossible to know which is the real best, So, what we are choosing, whatever are available, different surfaces generated through different options, variants of interpolation techniques, and that is the best. And of course, if you employ this like last option here is the barriers, you may get more realistic surface generation using this thing, and using this barrier polyline. So, likewise you can find the best possible interpolation techniques employing a random selection, taking out those selected points and later on using them in your analysis. Now, I will go for another demonstration which I told earlier, that we will go for this spatial resolution, different spatial resolution DMs which are available currently, and how these the quality you have to assess, because remember, quality is spatially or errors are spatially varying. So, for plane a particular area I may find SRTM is good, but for another area I may find ester is good, or in third area I may find cartosat is good. All may be on the same resolution. So, errors are spatially varying, and therefore, we cannot always rely on a single digital elevation model. Here what I am going to do, I am going to display one after another digital elevation models having different spatial resolutions, and then see how, then we will compare different spatial resolutions altogether of different layers or different DMs. The one which is being displayed currently is the topo, G topo or US GS topo, and that topo stands here from the source is topographic maps at 1 kilometer resolution, and this entire tile is for India. So, if whenever you download, the entire tile will come. But if I start zooming it, for example, if I zoom like this, I have started noticing that jagged things, that individual cells have started appearing very quickly. So, let us go back to that zoom level where we started. Okay. And what we will do, we will zoom to the layer, Now add another digital elevation model which is at 90-meter resolution, and this is based on the SRTM-DM, Shuttle Radar Topographic Mission. So this DM is covering a very small area relative to what 1 kilometer resolution DM is. So if I bring in the background and give a different palette or color here, so both things will be much easier to see. Oh, sorry. See, so this is what we can assess immediately the difference in different spatial resolution of two digital elevation models. In the background, that the colored one which you are seeing is USGS Topo 1 kilometer resolution DM, and on top of that you are seeing a 90-meter resolution DM of part of GTopo area. And as you can compare, see here, because each cell is representing 1 square kilometer, and whereas it is representing 810 square meter area, your SRTM, and the huge difference in spatial resolution can be clearly seen. Even if I give the same color palette or assign same color palette to this one, still there should not be any problem. See the difference, you can see where one is overlapping here, as you can see. So in the background you are seeing a digital elevation model at 1 kilometer resolution. On top of that you are seeing a 90-meter resolution. Now immediately you would realize that what is the huge difference which you are seeing here. Now let me also add one more digital elevation model of different resolution, and this is SRTM DM of 30-meter resolution. The extent is same, and that means if you see carefully the naming of the files, the tile size is same. But if you very carefully read the file, that it is telling that north 30, so that you can see that north 30 and 78. So the bottom left corner coordinates are written, plus also it is mentioning 3 arc second, and this is version 2. 3 arc seconds roughly stands for 90-meter resolution or 90-meter cell size. Whereas this one, the 30-meter resolution SRTM, though the origin is the same as the that one, as you can see, and the origin is same. So let me make this one as black and white to make things more better. And when I add this one, this is what I get here. So the tile size is same, that means the extent is same, but the resolution has improved again very significantly. From 90-meter or 3 arc second, now we have reached to 30-meter or 1 arc second. So if I compare these two digital elevation models, let me bring the same color to these two, and the USGS for time being I can switch off, and when I zoom a particular part or section of this digital elevation model, say here, and currently what you are seeing is 30-meter SRTM DM, and below here it is 90-meter, and you can see difference, not as that big one, but definitely you would see difference very clearly. So currently you can see these pixelized or jagged kind of pixels, or sorry, cells, but when I bring 30-meter, then I see much more smoother area. So this is another way of always try to zoom a part of input data and see what is happening there. because many times at that level, 1-to-1 scale level or 1-to-1 display level, you may not observe the problems or a quality of a digital elevation model for visual inspection, but when you zoom it, you can definitely see. Like here, which I am showing currently, again 90-meter SRTM, and this is 30-meter. So 90-meter and 30-meter, you can see how the difference in the spatial resolution. Now, what I am going to do is I am not showing now 90-meter. I will show 3 DMs of 30 meter each, generated through the same through 3 different techniques, generated through 3 different techniques, or 3 different sources are there, though all are having 30-meter spatial resolution, and also they are having the same geographic extent. So each tile is that 5-degree tile you are having, 5-degree, or let me check, 78, 1-degree tile. So each tile is 1-degree tile of DM of different sources. So the one which you are seeing currently, and this colored one, is a SRTM 30-meter, and this Astra DM, this is again 30-meter, and so the both have been generated using completely different remote sensing technique. SRTM based on SAR interferometry, Astra GDM based on stereo pairs, and Cartosat is also based on stereo pairs. And now at this stage you may not, what I will do, I will keep every elevation model having the same color here or same palette. So, and then let me zoom it. Is there any differences there or much difference? Because all 3 are of same spatial resolution. So see, even they are varying spatially. This is currently SRTM DM, SRTM DM which you are seeing here. Now I add the Astra GDM or DM of 30-meter, and I attach here the Cartosat. So all are showing a completely different way the terrain is. Now what is the true form of the terrain? It is very difficult to represent. So how you can assess, as we have discussed while discussing in theory about how to assess the quality of a digital elevation model. Now what you can do here, again you can employ those random points. You can generate random points for the same extent, like here, maybe 100 points or 200 points, and then enrich the database of that or attribute table of that random point with through all 3 digital elevation models. So in your random point attribute table, you would have a height field from SRTM, you would have a height field or elevation field of Astra GDM, and you would have another third field for Cartosat DM. And once you have collected all these points against those random points, now you can see that which is giving you can perform a simple statistical analysis, like example standard deviation and other things, and you can find that which one is giving minimum standard deviation, and probably or which one is more close to the points which I might be having for test points, and then you can assess again which one is the best. Another way which we have also discussed, while doing either surface hydrologic modeling and creating a drainage network or morphometric analysis, and then that will also give you insight about the quality of a digital elevation model. Currently these softwares have not implemented to assess the quality of a digital elevation model. But I am sure that since a lot of options are available, like for example at 30-meter spatial resolution, we are having now at least 3 freely available digital elevation models for India, and therefore we should have some mechanism or some tool by which we can assess that which one is the best for this my area of interest. As we have been discussing that a particular digital elevation model, say for example Aster GDM or Cartosat may be very good for my hilly area of study, and whereas SRTM is not so good, and SRTM may be good for plain areas, but there Cartosat and Aster GDM is not good. Now when we assess within Cartosat and Aster, both are based on photogrammetric techniques, then again I would like to know which one is more accurate. So there are no basically standard tools available, but the theoretical understanding or statistical tools are available. Only thing the random tools are also a random generator, random selectors in standard GIS softwares. By employing those things, you can definitely assess in a good way about the quality of a input digital elevation model of your area. But this exercise has to be done every time if you are changing the area. Suppose today I am working in a flat area or Indo-Gangetic plain area, then after assessment I find that SRTM is good, but I cannot assume the same assessment would be true in case of hilly terrain. So for hilly terrain area, again I have to do the assessment. I may find that Aster GDM or Cartosat DM is good than your SRTM DM. So every time if I shift in my area of interest or research, then definitely I should do the assessment of quality of a DM. If you are using your own generated digital elevation model, then its a scenario is different. You can check it with the 10% randomly selected points kept as a separate file, kept in a separate file, and later on once you have found that which one is the best interpolation, then you can employ all 100% point. But here you need some control points to check. If they are not available, then relative checking can also be done using random points. So there are various ways. Once you in theory things can be summarized, or a sequence can be given much easier way. But when we come for real practical things, many times you have to do some kind of innovations in terms of sequence, or you have to find out the most appropriate tool to do that work. So the manuals or books or literature will never tell you that how these things can be done. But if you are having such a very huge toolbox, only thing you have to find the most appropriate tool and then do the part. So there are ways are there always. You are having a rich toolbox, and find the most appropriate tool and perform the analysis which you are intending. So with this I end this demonstration. Thank you very much.